Welcome to the Math Record. Today I'll be covering the 2020-2021 CCML Video Contest 1, which I'll be answering the freshman sophomore questions and the junior senior questions. So usually for these type of contests, you want to be creative and get them right to get full points, or like somewhat almost full points. But what I'm going to be doing in this video is that I'm just going to be answering all these questions to kind of show it how it's done. And also because I just want to do it because the contest is going to be tomorrow, but I'm going to be releasing this video on that day. Okay, so first question, square SQRE has an area 1. The midpoints of the sides of SQRE are connected to make a new quadrilateral. What's the area of this new quadrilateral? So what we could do is just make a square, and then I'm going to make a quadrilateral. So the quadrilateral is going to be a square. I'm not going to prove why, and I'm also not going to use the property that it's a square, but it's good to know it. Okay, so we know that the area is 1. That means the side lengths of our square is 1, because 1 times 1 is 1. And these are midpoints, so that means the lengths of 1 are halved, so it gets 1 half. And then to get the area of our quadrilateral, we just need to subtract the area of our square by our 4 triangles. So to get the area of a triangle is 1 half times base times height. So 1 half times 1 half times 1 half is 1/8. So these are all 1/8 because it's a square, so they're constructed the same. So that means 4 times 1/8 is 1 half. That means 1 minus 1 half is 1 half for our quadrilateral. And that's our answer for A. Okay, question B. In parallelogram PGRM, PG is equal to 10, GR equals 6, the midpoints of the sides of PGRM are connected to make a new quadrilateral. What's the maximum possible area of this new quadrilateral? So let's make a quadrilateral. Connect it here and connect it. And then we also connect the midpoints. And here. Okay. So what we have is, let's just label. So let's call this P, this is G, this is R, and this is M. And PG is 10, so it's a parallelogram, so this is 10. And then GR is 6, so this is also 6. So first we need to find the area of our parallelogram, subtracted by our 4 triangles as we did in part A, to get the area of our quadrilateral. So let's first find the area of our parallelogram. So if we make a height, right? So what we could do is that we could label this angle as theta. That means this side length using trig is 6 sine of theta. So the area of our parallelogram is 10 times 6 sine of theta, right? Base times height. So let's delete that. So the area of our parallelogram is 6 times sine of 10 times 6 times sine of theta, which is just 60 sine of theta. Now the area of our 4 triangles. So we're just going to find one of them. So let's make a diagonal. And what I notice is that I have this triangle. Sorry about that. So this triangle, this big triangle, and this small triangle. So this triangle is made by the midpoints. So that tells us that this triangle is similar to this big triangle because this angle is the same for both triangles and these side lengths are similar. So based on that, since I know that the side lengths are halved, that means the area has to be square that, which is a fourth. So what is the area of this big triangle? Well, that's 1 half of A because we split it in half, and then a fourth of it would get the smaller one. So 1 half A times 1/4 would be 1/8 A. And you could apply the same logic with this big triangle and this small triangle. And if you draw this diagonal with this big triangle and this small triangle, this big triangle and this small triangle, so all of these would be 1/8 A. So that means, since there's 4 of them, that means the total area of our triangles are going to be 1 half A. So 1 A minus 1 half A is 1 half A. So that will be the area of our quadrilateral. So half of 60 sine of theta is 30 sine of theta. And now we just need to optimize this to get our maximum possible area. So the highest value that sine could go to is 1 because it goes between -1 to 1. So the highest value is 1. So 30 times 1 is 30. And that's your answer for B. Okay, question C. An isosceles trapezoid TRAP base TR equals 10 and angle ART is 60 degrees. The angle bisectors of the interior angles of the TRAP intersect in pairs to form the vertices of a new quadrilateral. What's the greatest possible positive difference of the measures of the two interior angles of the new quadrilateral? So what we could do, we could make a trapezoid, and specifically an isosceles trapezoid. Okay, so I know that angle R has to be 60, so TRAP. So TR is equal to 10, but that's going to be unimportant when we start doing this. We know ART is equal to 60 degrees. This is 60, this is 120, and this is 120 because it's an isosceles trapezoid. And then we draw angle bisectors. So right here, and here, and here. Okay, so let's find this angle first, and that's pretty simple. This is an angle bisector, so this is 60 because half of 120 is 60. So 60 and 60 means this is 60 because 60 plus 60 plus 60 is 180 degrees for this triangle. Now let's find this angle. So we could use this triangle. So this is angle bisector, so this is 30 because half of 60 is 30. So 180 minus 30 means this is 120. Okay, now we need to find these angles. And these are going to be the same because they're constructed similarly. So all we need to find this angle is that we need to find this angle. So this angle, we know that this is 60. We know that this is 30 because of angle bisectors. So that means 180 minus 60 minus 30 means this is 90 degrees. So it's a right angle. So that means this is a right angle and this is a right angle. So we wanted the biggest, like the greatest possible positive difference. Just have the biggest, which is 120, minus the smallest, which is 60, to get 60. And that is your answer for the last question for your freshmen and sophomores. Okay, now let's deal with the junior and senior questions. And let me zoom in. Oops, that's a little too much. Okay, so let's solve number one. A, solve for xy for our x plus 2y is equal to 3 and 4x plus 6y equals 8. So it's just a system of equations. And you can solve this by just using like addition or whatever. But I'm going to use a matrix. So 1, 4, 2, and 6. And we're going to multiply this with x and y. And that will be equal to 3 and 8. So if you want to solve this, you could just use the matrix way of doing it. So if we're going to solve the x, we substitute for the first one. So that's 3, 8, 2, 6 divided by the determinant of the original one, which is this. And then you want to solve for y, that is 1, 4. Substitute for the second one, which is 3, 8 divided by the determinant. So the determinant of this one is 18 minus 16, which is negative 2. Now the determinant of the original one is 6 minus 8. Um, sorry, this one is 18 minus 16, that's 2, sorry. And this is 6 minus 8, which is negative 2. So 2 divided by negative 2 is negative 1. So our x value is negative 1. I'll just put this on the side. Now our y value, so this is 8 minus 12, which is negative 4. And remember, this was negative 2. So that means negative 4 divided by negative 2 is equal to 2. And that is your answer for part A. So I'm going to delete this, and I'm going to substitute our x, y, because they're going to be really useful to solving B and D. So this is negative 1, 2. So let's go with B. So you kind of could just ignore how it's kind of written and just write the matrix form again. So the coefficients are 1, 4, 2, 6, and then you could just set it equal to 3 and the 8. So then we have 1 over x this time and 1 over y this time. And that is equal to 3 eighths. 3, 8. Okay, so as you see, this is the same as this. This is the same as this. So that means we would just set this one equal to this. So we have negative 1 is equal to 1 over x, and 2 equals 1 over y. That means x equals -1, and that means y is equal to 2. I mean, y is equal to 1/2. And that's all. So that is your answer for number B, -1 and 1/2. Okay, now let's solve part C. So we'll do the same thing, write in matrix. So the coefficients are 1, 4, 2, 6, as similar above. And then we have our inputs, which is cosine of x and sine of y. And then our outputs are 1 and 2. Okay, so this doesn't seem the same because this is 3/8 and this is 1, 2. So to make this into this, all we have to do is just add some kind of matrix to get that. So 1 to 3, we need to add a 2. 2 to 8, we need to add a 6. Well, this looks familiar. This is right here. So if you've taken linear algebra before, what you could do is that you could rewrite this as cosine of x times the matrix, your first one, which is 1/4, plus this matrix right here, which is sine of, plus our second one, which is sine of y, times our second matrix, which is 2, 6. And since we added a 2, 6 on this side, we need to add a 2, 6 on this side. So just add a 2, 6. And as you see here, we could distribute out our 2, 6. This has a coefficient of 1. So sine of y plus 1 times 2, 6. So we just put parentheses on it. Times our 2, 6. Would then equal to our 1 over 2 plus 2 over 6, which is equal to 3 over 8. That means if we rewrite this thing, oops, write this thing back into like this form, what we'll have basically, let's delete this just so I could show why this works. We have 1/4 back, so we just do the reverse thing. 1/4, 2, 6. And then we have cosine of x again, and then the second one now is sine of y plus 1 is equal to 3/8. So that means cosine of x is equal to -1, and sine of y plus 1, trying to show that the y is not adding by 1 by the equation, equals to 2. And now all we have to do is just solve this. So that's pretty simple. Cosine of x equals -1 is when it's at pi, so at pi radians. And then it doesn't have that pi because it goes around multiple times in a circle. So it happens at a period of 2 pi n, where n is some kind of integer. Okay, and then y, we could say y is when, so sine of y equals 2 minus this 1, so that'll be 1. So sine of y equals 1 when it's at pi over 2 radians, or 90 degrees. And then add another 2 pi, and let's just use some other coefficient, let's say m, where m is some kind of other integer. Because m and n doesn't have to be the same thing, because it doesn't matter because x and y are independent of one another. So that means these are our answer for number C, for questions part C. Well, thanks for watching, and I'll see you at the next math record.